Welcome to this explainer. Look, if you're keeping a saltwater reef aquarium, you know that managing water chemistry is, well, it's basically part art and part science. Today, we're taking a deep dive into the truly fascinating world of reef tank automation. We're going to break down our source guide on two of the absolute heavyweights in the hobby, dosing pumps and calcium reactors. We'll explore exactly how they work, how they differ, and honestly, how they can completely transform the health of your coral reef. Let's get into it.
Let's start with a very real question. Are you completely exhausted by the roller coaster effect of manual water chemistry? You know the drill. Manually mixing supplements, doing constant water changes just to keep up with what your corals are consuming. And inevitably, your parameters just swing up and down. Think of manual dosing like experiencing a massive torrential downpour once a day. But in the wild, corals are used to a steady, constant, gentle drizzle of nutrients. When your key parameters drift because of that roller coaster, coral growth just stalls, and your most sensitive species really start to struggle. They desperately crave that steady baseline.
To solve that roller coaster, we turn to automation. Here's our roadmap for this explainer. 1. The Chemistry Balancing Act. 2. Inside dosing pumps. 3. Inside calcium reactors. 4. Choosing your ideal setup. And finally, 5. Setup, tuning, and maintenance. Let's jump in.
Section 1. The Chemistry Balancing Act. Okay, let's dive into this. Before we even touch the tech, we've got to understand the foundational chemistry these machines are actually managing. Take a look at what our corals are consuming every single day. And look, stability here is the absolute ultimate goal, way more important than just chasing single perfect numbers. First up, alkalinity, often measured as DKH. This basically tells us how much carbonate and bicarbonate is available. These are literally the building blocks for the reef. Next is calcium, absolutely crucial for supporting skeletal growth. Then, magnesium. Magnesium is kind of the unsung hero here. It maintains ionic balance, basically keeping the calcium and alkalinity from precipitating out of the water so your corals can actually use them. And finally, pH, which plays a massive role, especially when we start tuning reactors. All these elements do this delicate dance, depleting as your reef grows. And that is exactly what automation seeks to perfectly replenish.
Section 2. Inside dosing pumps. All right, let's transition over to our first method of automation, which is hugely popular for its absolute precision.
So what is a dosing pump? It's essentially a highly controlled delivery system that drips measured amounts of liquid supplements at set intervals throughout the day. Most aquarists use these for two-part solutions, usually a calcium chloride solution and a separate alkalinity component. Imagine having a tiny, incredibly precise robotic nurse delivering exact milligrams of a supplement right when your corals are actively feeding. Because the pump operates on strict schedules, often tied right to your test results, it's perfectly designed to counteract that predictable daily consumption.
And this brilliantly illustrates why they're so effective. By spreading your daily dose into dozens of tiny liquid drops around the clock, you're providing a way smoother environment with much smaller corrections to your water chemistry. It completely eliminates that dreaded roller coaster effect of manual mixing. Instead of feeding your tank one massive meal all at once, it's like setting up a continuous, healthy snacking routine. They're just incredibly useful for tanks with steady consumption where you want pinpoint, targeted control over exactly what goes in and when.
Section 3. Inside calcium reactors. Now, let's shift gears and look at the alternative methodology. It achieves the exact same goal, but the mechanics, completely different.
A calcium reactor is a closed-loop style system. So instead of injecting premixed liquids, it actually dissolves solid media, typically aragonite or something similar. And it does this using carbon dioxide and recirculated tank water. By injecting CO2, the system drops the pH strictly inside the reactor chamber. That acidic environment essentially melts the solid media. It's a genuinely fascinating scientific process. You're effectively recreating the very foundation of the ocean floor right inside a controlled little chamber.
As that solid media dissolves, it turns into this nutrient-rich liquid called effluent, which is then sent directly back into the aquarium. And this effluent is just packed with calcium and carbonate alkalinity, providing continuous availability as your corals grow. Now, the trick is that the system is managed by carefully tuning the CO2 to hold that low chamber pH and then perfectly matching the drip rate of the effluent to your tank's exact demand. Getting that drip rate right is absolutely critical. If it drips too fast, you run the massive risk of pushing excess CO2 into your main display and crashing your overall pH. But when it's tuned perfectly, it's an incredibly powerful, continuous feeding machine. Section 4. Choosing your ideal setup. So we've got liquid dosing on one side and melting solid media on the other. How do you actually choose between them?
So, the crucial point is, your choice really depends heavily on your tank size, your coral load, and your overall automation strategy. Let's break it down. Dosing pumps, they're usually the champions for smaller to medium systems. They're absolutely perfect when you want straightforward adjustments to very specific targets. Like, say you test your water and realize you just need to bump up your alkalinity. A dosing pump lets you isolate and adjust just that one element super easily. Calcium reactors, on the flip side, are typically the go-to for larger, heavily stocked reef tanks. When your system has a massive ongoing demand, dissolving solid media just becomes a highly practical, efficient, long-term approach. It replenishes everything at the exact ratio the corals naturally consume it. Plus, if your setup is already relying on pH monitoring and smart controllers, a calcium reactor pairs up beautifully with that tech.
Section 5. Setup, tuning, and maintenance. Regardless of which system you choose, the way you install and tune it will absolutely dictate your success. Let's get into the practical side.
According to our source guide, most failures in either method come from simply skipping these exact steps. Step 1. You absolutely must measure your current baseline for calcium, alkalinity, and magnesium, and make sure your testing method is actually reliable. Step 2. Start with highly conservative settings. Step 3, and honestly, this is the hardest part for most of us eager hobbyists, just wait for the tank to respond. Do not rapidly adjust multiple variables at once. Just wait. Finally, step 4. Over time, you correlate your tank's consumption with your coral growth and gently refine your schedules. Gradual, incremental tuning is the absolute secret to a stable reef.
There's a really profound quote from the guide to keep in mind as you upgrade. Automation doesn't eliminate responsibility, it shifts it. So true, right? Well, you're no longer manually pouring liquids into your tank every single morning. You do have a brand new set of critical oversight responsibilities to make sure these machines stay safe and reliable.
If you choose the dosing pump route, your shifted responsibilities look like this. First, check your reservoir levels so the pumps literally never run dry. Second, monitor your tubing health. You want to catch any kinks or blockages long before they restrict flow. Third, you've got to calibrate those peristaltic pumps regularly to make sure they're actually delivering the exact volume they claim to be. And finally, ensure your solutions are fresh and stored right. The big risk to watch out for here? Overdosing or underdosing when your tank's consumption suddenly shifts, like if you drop in a huge colony of new corals or crank up your lighting intensity.
Now, if you go with a calcium reactor, your maintenance checklist is quite a bit different. Eventually, you'll need to physically swap out the exhausted solid media. You'll also want to consistently check your CO2 equipment, keep a close eye on the regulator, the solenoid, and your bubble rate. It's also super important to monitor for any clogging or flow issues in that effluent line. And crucially, maintaining a stable chamber pH is a daily priority. Quick pro tip for both systems. Using simple alarms for things like low reservoirs, pH deviations, or wonky probe readings is a total game changer. It gives you incredible peace of mind and catches any drift way before it becomes a real disaster.
Both dosing pumps and calcium reactors aim to maintain the exact chemistry your corals desperately need to thrive. They just do it in wildly different ways. Precise, scheduled liquid supplements on one hand versus continuous CO2-driven media dissolution on the other. If your demand is manageable and you want that targeted pinpoint control, dosing pumps are fantastic. But if your demand is massive and continuous, a calcium reactor might just be your new best friend. So which automation path will you take to conquer the demanding chemistry of your growing reef? Thanks for hanging out with me for this explainer, and happy reefing.